Appendix, Indifference curves. This chapter deals with an indifference curve, marginal rate of substitution, consumer equilibrium, deriving the demand curve. A preference map is based on the intuitively appealing assumption that people can sort all the possible combination of goods into three groups: preferred, not preferred, and indifferent. An indifference curve. Let's for example take Tina as an example, who tells us how she ranks combination of bottled water and chewing gum. Figure shows part of Tina's answer. She tells us that she currently consumes 2 bottles of water and 4 packs of gum a day at point C. She then lists all the combinations of bottled water and chewing gum that she says are as acceptable to her as her current consumption. When we plot these combinations of water and gum, we get the green curve. This curve is the key element in the map of preference and is called an indifference curve. An indifference curve is a line that shows combinations of goods among which a consumer is indifferent. The indifference curve in figure tells us that Tina is just as happy to consume 2 bottles of water and 4 packs of gum a day at point C as to consume the combination of water and gum at any other point along the indifference curve. Tina also says that she prefers all the combinations of water, and gum above the indifference curve, the yellow area, to those on the indifference curve. These combinations contain more water, more gum, more of both. She also prefers any combination of the indifference curve to any combination in the gray area below the indifference curve. These combinations contain less water, less gum, or less of both. Part B shows 3 indifference curves of Tina's preference map: I0, I1, I2. Tina prefers any point on the indifference curve I2, such as point J, to any point on indifference curve I1, such as point C or G. She prefers any point on I1 to any point on I0. We refer to I2 as being a higher indifference curve I1 and to I1 as being higher than I0. A preference map is a series of indifference curves that resemble the contour lines on a map. By looking at the shape of the contour lines on a map, we can draw conclusions about the terrain. Similarly, by looking at the shape of the indifference curve, we can draw conclusions about a person's preferences. Marginal rate of substitution. The marginal rate of substitution is the rate at which a person will give up good Y, the good measured on the y-axis, to get more of good x, the good measured on the x-axis. At the same time, remain on the same indifference curve. The marginal rate of substitution is measured by the magnitude of the slope of an indifference curve. If the indifference curve is steep, the marginal rate of substitution is high. The person is willing to give up a large quantity of good y to get a small quantity of good x while remaining indifferent. If the indifference curve is flat, the marginal rate of substitution is low. The person is willing to give up only a small amount of good y to get a large amount of good x and remain indifferent. Figure shows how to calculate the marginal rate of substitution. Suppose that Tina consumes 2 bottles of water and 4 packs of gum at point C on indifference curve I1. We calculate her marginal rate of substitution by measuring the magnitude of the slope of the indifference curve at point C. To measure this magnitude, place a straight line against or tangent to the indifference curve at point C. Along that red line, as gum consumption decreases from 8 packs to 0 packs, water consumption increases from 0 bottles to 4 bottles. So at point C, Tina is willing to give up 8 packs of gum to get 4 bottles of water, or 2 packs of gum per bottle. Her marginal rate of substitution is 2. The red line at point G tells us that Tina is willing to give up 4 packs of gum to get 8 bottles of water. Her marginal rate of substitution at point G is 4 divided by 8, which equals half. Diminishing marginal rate of substitution. The general tendency for the marginal rate of substitution to decrease as the consumer moves down along the indifference curve, increasing consumption of the good measured on the x-axis and decreasing consumption of the good measured on the y-axis. The shape of a person's indifference curve incorporates the principle of diminishing marginal rate of substitution because the curves are both towards the origin. Consumer equilibrium. The consumer's goal is to buy the affordable quantities of goods that make her or him as well as possible. The indifference curve describes the consumer's preferences, and they tell us that the higher the indifference curve, the better off is the consumer. So the consumer's goal can be restated as to allocate his or her budget in such a way as to get onto the highest attainable curve. The consumer's budget and the price of the goods limit the consumer's choices. The budget line summarizes the limits on the consumer's choice. We combine the indifference curve with the budget line to work out the consumer's choice and find the consumer's equilibrium. Figure shows Tina's budget line from and her indifference curves. Tina's best affordable point is 2 bottles of water and 4 packs of gum at point C. Here, Tina is on her budget line, is on her highest attainable indifference curve, has the marginal rate of substitution between water and gum equal to the relative price of water and gum. Every point on the budget line lies on an indifference curve. For example, point F lies on the indifference curve IO. At point F, Tina's marginal rate of substitution, the magnitude of the slope of the indifference curve IO, is greater than the relative price, the magnitude of the slope of the budget line. Tina is willing to give up more chewing gum to get an additional bottle of water than the budget line says she must. So she moves along her budget line from F2 towards C. As she does so, she passes through a number of indifference curves located between indifference curves IO and I1. All of these indifference curves are higher than IO, so Tina prefers any point on them to point F. When Tina gets to point C, she is on the highest attainable indifference curve. If she keeps moving along the budget line, she starts to encounter indifference curve. If she keeps moving along the budget line, she starts to encounter indifference curves that are lower than I1. So Tina chooses point C, her best affordable point. At the chosen point, the MRS, that is the magnitude and slope of indifference curve, equals the relative price, the magnitude of the slope of the budget line. Deriving the demand curve. To derive Tina's demand curve for bottled water, we change the price of water, shift the budget line, and work out the new best affordable point. Figure shows a change in the budget line and change in consumer equilibrium when the price of water falls from $1 a bottle to 50 cents a bottle. Initially, when the price of water is $1 a bottle, Tina consumes at point C in part A. When the price of a bottle of water falls from $1 to 50 cents, her budget line rotates outward and she can now get on to a higher indifference curve. Her best affordable point is now point K. Tina increases the quantity of water she buys from 2 to 4 bottles a day. She continues to buy 4 packs of gum a day. Figure B shows Tina's demand curve for bottled water. When the price of water is $1 a bottle, she buys 2 bottles a day at point A. When the price of water falls to 50 cents a bottle, she buys 4 bottles a day at point A. When the price of water falls to 50 cents a bottle, she buys 4 bottles a day at point B. Tina's demand curve traces out her best affordable quantity of water as the price of the bottle of water varies.